you very much. I couldn't agree with you more in terms of the new paradigm in biotechnology. So I'm going to be talking about this as we go forward. But before I get started, I want to thank everybody here at TMU for inviting me. It's been, so far, we're on the second day. It's been a great experience. The food has been probably the best food I've ever had in my life, so I appreciate that. So thank you for taking the time to attend my talk. So I'm going to focus on entrepreneurship, and specifically entrepreneurship in biotechnology and in healthcare, which is a different beast than entrepreneurship in technology. And as you can tell, the name of my talk is Entrepreneurship in Biotechnology, or How to Not Fail. And the reason for that is I don't want to be so audacious as to tell you how to succeed. I don't really know, but I do know there are some ways that you will definitely fail. So I'm just going to discuss those, and hopefully you can figure the rest out for yourself. So before we get started, a short introduction to my background. I studied electrical engineering and computer science at MIT. I did PhD research in the artificial intelligence lab at MIT and in the computational and systems biology program at MIT. And I've also spent a lot of time launching ventures, both within academia and outside of academia. So these include the MIT Biotech Group, which was a new organization run within MIT, a couple of mentor group, a laboratory space, and also an alumni agency that's affiliated with MIT. So I'll talk about each of these in turn. So to continue off of the new paradigm that you mentioned, there's a variety, in my view, is that there's a variety of technologies that are reaching the point of affecting biotechnology and affecting healthcare, and transitioning healthcare from a largely random, experimentally driven discipline to more of an engineering, scientific discipline. These include sequencing technologies, DNA synthesis, gene editing tools, and all of these are increasing at rates beyond that are super exponential. So they're actually outpacing Moore's Law, which many of you are probably familiar with, being in Taiwan, one of the centers of semiconductor industry. And these technological developments are catalyzing what I call next generation therapeutics. So therapeutic regimes that are driven by technology rather than by kind of old experimental processes. These include cell-based therapies, microbiome-based therapies, nucleic acid-based therapies, all of which are targeted and specialized on an individual level rather than a broad spectrum approach. So these next generation therapeutics are really characterized by two things. One is a move from trial and error-based approaches to rational design, resulting in an increase in efficacy. And then also through an approach treating broad populations to very targeted subtypes, which results in increased accuracy and precision. So, this is similar to the precision medicine approach. The current therapeutic strategy is that you have a very broad patient population. That's not only broad in terms of biomarkers, but even people from Taiwan, people from the US, people from Africa, all of them have very different body compositions. But they're all treated the same way, which results in a diverse response profile. Some people respond well, some people respond poorly, some people don't really have any response at all. And then you end up having low average efficacy of your therapeutic treatments. And what we're moving to, enabled by AI and these other technologies, are stratifying the patient population into many different subtypes, and then developing targeted therapies for each subtype, which results in each subgroup having high average efficacy with a low number of side effects. So this broad idea of technology pushing forward healthcare and biotechnology starts with the technology catalyst and is leading to these next generation therapeutics. And it's disrupting the traditional healthcare market. So if you look at new companies founded in cell-based therapies, microbiome therapies, nucleic acid-based therapies, I mean, this group right here is billions and billions of dollars of market capitalization. Okay, so the question is, how do we catalyze? It's great that there are billions of dollars in next generation therapies, but how do we really catalyze more of this? How do we spur this innovation? Because some of this happens naturally. Who this is? Sistine Chapel, right? Who said that? Nice. So who painted the Sistine Chapel? Michelangelo. Wrong, see? Michelangelo did paint the Sistine Chapel, but actually there were 16 people involved, at least, that also painted the Sistine Chapel. So the takeaway from this for me is that not just the Sistine Chapel, but new technologies. We have this idea that they're driven forward by one person or one individual or one research group, when in reality, all of these, if you look throughout history, these exciting developments, whether they're in arts, whether they're in science, whether they're in technology, whether they're in entrepreneurship, are group efforts, and they're led by highly effective, great groups. So the question for me is, everybody talks about how do we have better technology, how do we find more exceptional individuals, but nobody really talks about how do we create an environment that leads to the creation of the Sistine Chapels of biotechnology and of healthcare. How do we create a holistic, exciting, synergistic, innovation-focused environment? I think this is actually critically important, and so what I'm going to do is discuss ways in which this does not work through ventures that have been involved. So another brief aside. How many people here study computer science or philosophy, either one? Okay, a few of you. So anybody been exposed to prepositional calculus before? Okay, so it's basically a branch of logic that's concerned with the study of prepositions, whether they're true or false, and how you can combine these in different ways, and then deduce the true or falseness of the combined statement. So you have, a new language here. This arrow represents or, like this. This arrow represents and. So if you have a statement that's P, N, Q, that statement is true if P is true and if Q is true. If it's or, that statement is true if P is true or Q is true. We also have notation for not, which is the opposite. So if P is true, then not P is false. And if P is false, not P is true. So we'll come back to this. But my contention here is that the Sistine Chapel would not have been possible without collaboration between Michelangelo and other exceptional trained artists. So if we're going to phrase this in prepositional logic terms, we have, no collaboration between Michelangelo and others leads to no Sistine Chapel, or not collaboration implies not Sistine Chapel. And then there's another statement, there's another method we can use called the contrapositive, so we apply this law here, and we get Sistine Chapel implies collaboration. This is one reason that universities were formed, right? To encourage collaboration. If there was no need for collaboration, there would be no need to co-locate academics in places where they could work with other people. But note that we have Sistine Chapel implies collaboration. We don't have collaboration implies Sistine Chapel. And the reason for this is that collaboration alone is not sufficient to produce something magnificent like the Sistine Chapel. But it is necessary. And speaking of universities and collaboration, I have evidence for this. So, and this evidence is that innovation actually varies enormously between universities, all of which collaborate, right? Every university has collaborations. That's effectively one of its main purposes. But the actual innovation that comes out of these universities is extremely disparate. So, for example, if you collect all the universities in the US and you make a pipeline of innovation, so you start with research expenditures, money going into research, and then you go to invention disclosures, patent applications, patents issued, options executed, startups, and then income from these startups. And you graph what percentage of all of the innovation comes from the top 1% or the top 20% of universities. You find that almost 40% of all innovation comes from the top 1% of universities. And over 80% of all innovation comes from, all translated innovation, startups, comes from the top 20% of institutions. So the bottom 80% in the US of institutions produce less than 20% of technology transfer. So what are they doing? So the takeaway here is that the majority of research organizations, the vast majority, contribute very little to overall technology transfer, regardless of how that commercialization activity is measured. And you can quantify this in the method used in the social sciences called the Gini coefficient. And if you look at the inequality quantified by the Gini coefficient across the technology transfer pipeline, you find that it's actually significantly more unequal than Saudi Arabia's income inequality. So it's extremely unequal. And so the takeaway from all this for me is that collaboration is necessary but not sufficient. There are other things involved in creating these hyper-productive universities that are really centers across the entire world of innovation and entrepreneurship. So I want to explore some ways in which those can be created, or ways in which you can fail at creating those. So chapter number 2, how to fail at innovation in biotechnology. So the great way to fail, number 1, is only work with people who have the same experience, the same education, the same upbringing, the same social status as yourself. It's comfortable to work with people who are the same. It's difficult to understand people who have their pants up high versus people who have their pants down low. At the end of the day, this is all very superficial, and it's actually necessary. I mean, if you don't talk to anyone who has their pants up high, you're going to miss out on an entire generation of knowledge, right? So an organization that I created that kind of speaks to this is the MIT Biotech Group. The goal of the MIT Biotech Group was to create a centralized hub for translating biotechnologies at MIT. And the way that we addressed this was by centralizing communication across the MIT ecosystem and involving members from basically every department at MIT. So we had people from the business side, we had people from biological engineering, we had computational biologists, we had electrical engineers, we had mechanical engineers, we had physicians, we had physicists. We actively recruit from every department across MIT, which if you've worked in a school can be difficult given the politics that exist between different departments. And we've gone beyond this to actually build a network that expands beyond MIT into the surrounding biotechnology ecosystem. So we have this is just a small subset of the companies in the Cambridge area that we've had very active collaborations with. And we share these connections very openly. So if you join the MIT Biotech Group and you want to get connected to someone at any of these places, it's very easy to find someone that can introduce you to someone in these organizations. So this leads to collaboration between industry and academia, as well as just within different departments in academia. And we've kind of institutionalized this approach by creating a unique group structure that we haven't seen before, where we have an executive team and then we have project managers, and the project managers recruit individuals to be part of their project. And resources get allocated between these projects based on interest. So everyone's incentivized. If you create a project and there's a lot of interest, and people will join your project, you get to lead it, so you're the project leader. Everyone else gets to benefit from your experience, and then resources are allocated to you based on need. So we've had a lot of success with this model. We launched in August 2015. I show this picture a lot. This is our first event, and we expected maybe 20 people to show up, and we had 300 people. The line went all the way outside of the building and around. So we had 4 members when we started, and now we have over 2,000 members at MIT, and a leadership team of over 30 people, most of whom are actually not paid. A few people are now paid by MIT because they realize this is valuable, but most are unpaid. And through this structure, we've launched many initiatives. And this is just a small subset of what we've launched. I'll talk about 2 of them. But the takeaway here is that you can have unique, highly impactful projects naturally arise when you have talented, motivated, and interdisciplinary teams. When you create these teams, these things just happen. So one of the initiatives that we launched that was led by Tony Talesa at MIT is Synapse, which is an online bi-weekly report for the Boston area biotech Biotech scene for students with advanced training, so graduate students in life sciences. And what Synapse does is sit down with successful biotech founders, CEOs, entrepreneurs, and kind of bring you their stories and how they got to the position they were, which makes it, sounds maybe a little bit trite, but when you're a graduate student with aspirations to go into entrepreneurship and you don't have any role models, it can seem very difficult. But then when you have personal stories from people who have gone through this process, suddenly it seems like something that can be done. We've also collected all the startup resources that exist across Cambridge and Massachusetts and MIT and Harvard and kind of compiled them into a single website. So you can go everywhere from getting an internship to finding a co-founder for your company, to finding advisors, to competitions, to accelerators, and even legal services. So you can very easily go here and find where to go for the next step. And this is available for everybody, synapse.mit.edu. Another thing that we've launched is research experiences in biopharma. So this is a unique class that was led by Nathan Stebbins and Reagan Redden at MIT. It's a new educational model for exposing graduate students to the biotechnology industry. The reason that we launched this class was that we did a survey of all of MIT and found that almost over 40% of people thought that part-time internships would be the best thing for them to learn more about industry, But there were barriers there, which is why it's never been done before. Advisors, if you're the professor of a graduate student, the last thing you want is for your graduate student to go and do an internship somewhere else and not be working for you. And also funding is difficult. So if you go work for someone, who pays for it? So we created a course. That was our way around this. It addresses funding restrictions because if you enroll in a course, that doesn't compromise your funding. And it's provided for free to the companies. Advisors, professors are pretty comfortable with courses. They're used to people taking classes. It's a 12-hour commitment, and it's accessible across all different departments. Plus, it provides added benefits. MIT partnership, we have a class where students can discuss with other students who have similar interests. And it's a networking opportunity for people to meet other people around in the biotechnology industry. So the takeaway from this is that if you don't have a diverse team, it's another way to fail. So far we have two ways to fail: lack of collaboration and lack of a diverse team. Okay, so a great way to fail number two: avoid advice and feedback, especially from people that are more experienced than yourself. So to address this, a related venture is the MIT Alumni Angel Group of Boston, Life Sciences Track, which I co-founded about a year and a half ago. What we do here is we take MIT students and entrepreneurs who have exciting new technology and who they have a lot of energy, they're driven, but what they lack is experience, they lack advice, they lack connections, and we host a forum where the most promising ones that we select present to a select group of MIT alumni who have experience in biotechnology. They're typically entrepreneurs, executives, professors, doctors, people who have very deep area expertise. And we facilitate this collaboration where the MIT students and entrepreneurs, they will involve these people in their new ventures. And then the later stage alumni provide advice, connections, and they can also invest if they choose, so they can provide capital at a very early stage, which creates this beneficial ecosystem that didn't exist before. And you would think this is a simple thing to do, but so far we've held 5 events, and we've had over 20 companies go through this process, and about 50% of them have raised between $150,000 and $500,000. They've gotten several advisors. It's really been a catalytic event for these companies. They bring on very experienced people. They get enough money to get started. It's really helped them along. So next rule is no feedback from others is another failure mode. We're accumulating ways to fail. So there's 2 more. Great way to fail number 3 is to get trapped in the valley of death. So that's basically not having money is a great way to fail. And the reason for this is that there's a lot of money in the basic science side of things. at least in the US, there's a lot of money for early stage research. And there's also a lot of money for validated research. There's a lot of venture capitalists who, once you prove that you can make $1 billion, they'd be very happy to give you some money to own part of it. But there's not many people who are in between, who are willing and able to understand technology, kind of invest in technology at an early stage, and then carry it through to the later stage. So to this end, this is an organization that I once co-launched that was outside of MIT. It is Nest Bio Ventures. So we're a venture group whose mission is to provide resources for really revolutionary next generation companies that are driven by hard technology, next generation therapeutic companies that are difficult. We're all PhD trained scientists, and we really gravitate towards the kind of technologically intense, scientifically challenging companies that most people shy away from because they're very risky. We also gravitate towards founders that are young, or founders that have unique backgrounds, because we find that they're undervalued often. Often those backgrounds provide enormous value, but they don't fit the traditional, model of venture. So we gravitate towards all these people. And we have kind of a unique model where we focus, we're all scientifically trained, we all have unique, specialized focuses. So my background is in machine learning, artificial intelligence, and that's the area where I specialize. So we look at companies that fall into whatever our area of expertise is, and then either evaluate them, or actually if we find a gap that's not being filled, we will work with people in academia and work with local entrepreneurs to actually spin out something that addresses the problem that we find. So we go very, very early stage. So not being able to cross the valley of death is another failure mode. And the final one is the great way to fail, number 4, is work with people who do not have the same goals as yourself. It's actually very common, but a great failure mode. So I've seen many companies fail through this process. And so I'm going to talk a little bit about an example. So one example of this is in Cambridge, rent and laboratory space is extremely expensive. So companies who get launched, they have to pay for laboratory space and rent. But usually the person that they pay is not the person who wants them to succeed. That person is, a landlord who wants them to get as much rent as possible. But they don't benefit if you are successful, right? So what we've done is created a separate co-working laboratory and office space that provides, fully equipped, fully permitted, ready to move in immediately laboratory and office space in the center of Cambridge for new biotechnology startups. And typically these will be companies that we've invested in some way or another, either capital or advice or friends of ours or something. So we're really motivated for them to succeed. We're not trying to get rent from them or something. We're located in the middle of Cambridge, and so these companies kind of create a holistic environment, all of which are aligned to see the eventual. They benefit when companies are successful, and not through any of the derivative kind of values of companies. So the final one is, if you do not have aligned incentives, that's a great way to fail as well. So to wrap everything up, let's tie everything together. So we're going to go back to propositional logic here, propositional calculus. If you do not have a diverse team, or you do not have experienced feedback, or you're not able to cross the valley of death, or you do not have aligned incentives, then you'll probably fail. And so there's some more laws that we can take from propositional calculus to kind of modulate this statement here. So De Morgan's law, which is up on the top, we can apply this and see that if you do not have diverse team and experienced founders and cross the valley of debt and have aligned incentives, then you'll likely fail. And then again, we can use the contrapositive, which we introduced in the beginning of the talk. And so the final statement that we come up with is, if you don't want to fail, if you do not fail, then that implies you have a diverse team. It implies that you have experienced feedback from those that are more experienced than yourself. It implies that you have the ability to cross this valley of debt between basic research and translation, and you have aligned incentives. So this is, clearly there's other things involved here, but this is 4 ways in which you definitely could fail if you wanted to. So that's the end. I think I hope you've learned a couple ways in which you could fail if you want to start your next venture, and hopefully that you can avoid. So I want to open this kind of workshop up for a more discussion about these topics and hear more about the Taiwanese side of things, because this has all been very focused on MIT, and I know it's very different across the world. But please feel free to reach out either via email or social media, and I'll try and get back to you as soon as possible. So thank you very much.
Thank you, Dr. Weis. It's a very interesting point of view, and thank you for sharing of us. And I know we learned from management school, most of the professors will tell you how to succeed. But I think this is a very valuable lesson that we can bring home here today. And I think we have enough time now, so I think we can open the forum now for everyone here to share. Maybe Dr. Lee, you want to share first?
I once heard a statistics about the percentage of successful business that's created from the MIT Business School, or just law school business, right? Yeah. And that success rate is like less than 20%. Yeah. And that's from the MIT people. Yeah. But if we're not from MIT, what would be our success rate? I mean, how much does it cost before you succeed?
So that's a good question. I mean, maybe you can speak more to the success rate here than I can. But I think one way to look at it is that, if MIT can hit a 20% success rate, then where else, what would be the possible rate in the rest of the world, assuming that it would be lower. But on the other hand, there's a lot of competition at MIT for funding and for companies. Every technology has multiple people who would like to commercialize. The ones that are clearly commercialized. So it may be a higher percentage here, just because you have the opportunity to avoid that whole, that whole thing.
Well, there are quite a few sort of like incubator in Boston area. There's a lot of reports. And what makes your nest coming out of all this incubator, and how can you actually help those startups, especially in, I think you mainly focus about biotechnology, isn't it? Yeah. So how would you differentiate yourself from others?
Yeah, absolutely. So I think one of the main problems with the incubators that exist are that they are not equity holders in the companies. And if they are, it's not very significant. So it'll range from 0% to like 7% or something like this. Maybe 10% at the most. But the problem with that is, like I mentioned, the probability of success for any one company is very low. So they actually make a lot of money through just having the companies there and charging them for services that ends up being their business model. And I don't think that leads to alignment among incentives. So I think it's a unique model to invest very heavily in companies and then provide them the infrastructure that they need to survive, basically. Because then your incentive is, you succeed if the company succeeds, and not any other way.
So for a new startup to join Nest, so it's a prerequisite that they would sort of pass your investment reviews, and then you become their shareholder, then join Nest.
So about 50 to 60%, yes. And the rest are companies that we've selected specifically because we think they add value to the space. So it could be really exciting founders or really exciting technology. We're trying to create, and the reason we do this is because we want to bring companies that we think bring value to the companies that we invest. So, the goal here is to create a holistic and positive environment for the companies that we invest in. And that tangentially allows other companies to get involved as well.
Great. I think that we can clone that idea to here in Taipei Medical School.
And my question is about what are the opportunities and challenges for ICOs for MIT startup and elsewhere. For example, if we start here, you think we get enough funding through ICO, or you think it will not work?
For ICOs in terms of initial coin offerings?
Yes.
So we're talking about cryptocurrencies now. Yeah, okay. So how can you create a startup by selling Bitcoin or Ethereum? How many people are familiar with cryptocurrencies here? Bitcoin and Ethereum? Well, you should learn more because it's a very exciting area. I think it's a new area. So in China, for example, there's been billions of dollars of money, raised through offerings of these cryptocurrencies, and then the Chinese government just banned the whole thing. So you can still do it if you go to Hong Kong or Switzerland or somewhere, but I think it's not really a fully proven model. I think so. One of the first initial coin offerings was Ethereum. And Ethereum was offered through Bitcoin, and they created a separate token. They raised money by selling Ethereum, and now Ethereum is over $1 billion valuation. It's used throughout the world. So I think it's a really interesting combination of spaces. So like I was telling you earlier, I think there's a lot of opportunity in cryptocurrencies in general, but especially in health technology, raising money through blockchain.
Good.
You mentioned that the inequality in the Chinese universities, especially from the top 20% university and the last 80% universities. So what kind of role the universities who is not in the top 20 list what kind of role they should play in the technology innovation ecosystem?
That's a great question. I don't know. I wish that someone could figure out the answer to that. So I think there's two possible solutions, right? One is taking the lessons from those highly performing universities and applying them in these less performing universities. And I think that's probably the way to go. So I think there's a lot of really untapped talent in these other universities that just is not able to progress from research to translation because there's not the structures in place to help them succeed. So for one of the examples, if you look at the companies that, if you look at the universities in the top performing list, right? Almost all of them, if not all of them, have very large technology transfer offices. They have something like 20 plus people. If you look at universities that are not very high, they all have very small technology transfer offices. So one potential takeaway from that is that universities need to invest in their technology transfer offices and create organizations like the MIT Biotech, or even just allow their students to create organizations. I think there's a lot of opportunity. The other, the more pessimistic side of things is just stop funding those universities entirely and put all the money into the top performing.
One of the other approach following that question is that people have been always talking about there is no medical school in MIT, right? So would that possible, probably MIT or Harvard is good enough, would that help if MIT merged with Harvard school? Okay. The reason for asking this question is that this approach the Chinese guys have been doing. They come up with the mega university. So maybe the top 20 university, they will merge with the small guys and then they merge into it's actually like Beijing University and Tsinghua, they merge with some small university. And plus, on top of that, they also merge hospitals. So it's like merging with teaching hospitals. In that case, will that help in your comments?
These are all very good questions. So I think, MIT and Harvard have a very symbiotic relationship, right? So like Leo and several other speakers here are involved in IMES and Health Science and Technology Program, which is a joint program between MIT and Harvard, specifically focused in health technology, with the idea of taking, technology-focused people from MIT and giving them access to medical school. So they're already somewhat merged, but I definitely have spoken with people from the MIT Corporation who predicted that in the next 20 years, MIT and Harvard will become one university. I don't know if that'll happen or not, but that's what I've heard.
That would be interesting. How would they call that university name? MIT, Harvard or Harvard MIT?
There's a Pro Institute already.
Yes. Yeah.
So they collaborate with each other, right? So there's no need to merge the schools.
But it could be the case that sometimes it's easier to collaborate with people from a different university. So you don't have to be necessarily in the same university to work with each other. Actually, if you're in the same university, you're probably competing for the same piece of resources. And so sometimes it doesn't facilitate the collaboration by combining all the other different universities or hospitals in that sense.
No, I think that makes sense.
We do have a technology transfer office. I think that they have almost 20 people here in this building on the 20th floor, on the top floor. So I guess that this building was designed to serve partially as a purpose to foster new ideas and new entrepreneurs. But the problem is that we are not, we don't lack people who have ideas. But again, there seems to be a very big gap from ideas to business, So, because there are many different steps. I mean, there's so many steps that you put down in each of them before you become a sustainable business. So, what would be your advice? I mean, besides those steps, those advice about how not to fail. What would you advise people, a group of young people who have good ideas and they think this is probably translatable to a new business? What should they do for the first few steps in order to not to fail very early?
Yeah, no, it's a good question. So I think from the university perspective, there's an opportunity to create a structure that can help people through the whole process. So, for example, MIT just launched the Engine, which is an MIT affiliated venture fund, and the goal of it is to help provide, connections, capital to MIT companies. But MIT has a very thorough. I wouldn't say it's perfect by any means, but there's a lot of kind of organizations within MIT that are created for different steps along the path. So if you're very early stage, or if you're trying to raise money, or if you're later stage, there's the Martin Trust Center for Entrepreneurship. There's a lot of structures in place to help people through that process. There's even classes, that are specifically for people who have ideas, how to access the rest of MIT and how to get it off the ground. So I think it's an opportunity for universities that don't have that structure, like the bottom 80% in the U.S., to create something like that. For students, I think if that's not in place, the number one thing is to seek out what is available and try to take advantage of it. And I think the biggest resource, probably here and in many places along the world, is other people who work in. Academic institutions themselves are hubs of innovation. They attract interesting, smart people, even if they're not professors. Many of them are, but even people from industry often will come and get involved with this. They serve as kind of central nodes. And if you're a student here, I would take advantage of that and just try and talk to as many people as possible. And eventually you'll expand out of this node and you'll get connected with people who can help you. I'm sure there's people in the audience here who have ideas. Just in the first 3 rows, there's probably sufficient experience to really be helpful. So.
Another random question is that, in Taiwan, we sort of have this idea that if you're a student, you should stick to your academic works. And if you want to create a business, you have to wait until you graduate. Right? So what would be your advice for undergraduate students in the university as well as graduate students like yourself?
So I think sometimes that school can be a little bit too safe of a place. And you can stay in school and you can study with the idea that eventually you will do what you want to do. But in the meantime, you're secure, you're safe in school. So I would say my advice would be just if you have an idea, you know what you want to do, start getting involved as soon as possible. I mean, while you're here at school, you have access to such a broad array of people who can be extremely helpful in the process. So I would take advantage of it. So if you wait until you graduate, you still have connections to alumni, but you're kind of gone from this environment. So I would try and get started as soon as possible and just stay up later at night if you have to.
To actually add to Ken's comment and to actually respond to the earlier queries about the differences between communities, there's actually the most ambiguous and unhelpful answer is that culture actually makes a significant difference. And I don't want to sound critical, but from my experience of visiting Asia, a lot of it is hierarchical and somewhat restricted. One of the great things and unique things about Harvard and MIT, even compared to other universities across the U.S., is that they really empower them to take risks and to explore and to basically, a startup is a risk. So taking these ventures is a complete risk, but they give them the opportunity to take these risks and to actually fail, and provide these supportive environments. And I think it's very challenging to replicate this in many other environments. But because they have these high-performing students and they have these students and communities that are interested in taking these risks, all they have to do is take a very passive role and just create supportive environments like the Harvard Innovation Labs, the Trust Center, and basically just provide all this infrastructure for the students to be proactive and to take their risk and to jump into it. To create this environment in a novel situation is going to be very challenging. It's going to have to take a lot of infrastructure and investment at the early stage without an immediate return to provide, to get the signal to the students that they are encouraged to take these risks, to take these gambles, and and still have the provided structure and to get the return so that they will want to take these risks. So it's very challenging. I don't think there's an easy way to replicate the things that are taking place in Harvard and MIT, but I think there's some good lessons to be learned from them.
But that leads to another question about what happened after you fail. As we just discussed, there's 80% chance even MIT people will fail. But what happened after you have failed? If you have a cushion or a safety net, a soft landing type of failure, then people are not that afraid to try, right? So for young people, they have to raise money like $100,000 US, and then they end up with nothing after 2 years, 3 years. That's too much of a risk, right? So they wouldn't even get started, even though they have the team, they have the idea, but that's too much of a personal financial risk to them.
No, I totally agree, and to echo what Ken said, definitely have noticed that in many countries, the stigma, the risk of failure, or just the stigma of potentially failing is a major reason why people don't get involved in these. And I think one of the unique attributes of kind of the Cambridge area or the MIT ecosystem is that, and it's the same in Silicon Valley, is that failure is not viewed as failure, really. I think that if you meet people at MIT, for example, and they say, I raised $1 million for this company, it was awesome, I quit my, school, whatever, and then it failed. People will view that as if it was a cool thing that you did, right? And if you go take a job, people will look at you and say, okay, well, this guy, worked for, 4 years and it's fine, but this guy actually took a risk, left, failed, and came back, and some employers will view that more positive. And that's definitely not the case in many places, I would say the majority of the world. One of the most interesting, something I'm working with one of my friends, and who's really leading this whole thing, is there are some interesting models to address this. Because even amongst people, at Harvard and MIT, prestige is a very big driver, right? They want to get involved in things that are prestigious, that have other people that are, very talented and successful. So an example of this actually is Teach for America. I don't know if you're familiar with Teach for America. But Teach for America is effectively you graduate from a top university and then you go teach at a school in like a disenfranchised area. And you don't really get paid. You have no compensation of any sort. except that Teach for America is a prestigious thing. Someone just decided to make it a prestigious thing. It's like hard to get into. So now, because it's prestigious, all these top graduates will go and work for free for 2 years. And, you know, so it's a good model, I think. And one of the ideas that could work, for example, the Y Combinator model, there's a couple fellowship models where you can get involved, you get accepted to this, maybe you get some funding, maybe you work with professors or whatever, and it's kind of a 1 or 2 year opportunity to launch something with the soft landing, right? So if it doesn't work, then you got accepted to this fellowship program, it's still a positive thing, and then you go back in and you do something else. But I think you're 100% right that you need to think about how to create structures that kind of support people if they
Is it more available, like in the U.S., in terms of safety net for people who fail?
It's a hard question. So, I mean, if you start something during school, that's a good way to be safe, right? Because if it fails during school, then you're still in school, or you can go back to school.
I think Elon Musk is a good example of failure and how he got up. After whatever he did initially, everything failed, literally. And then now he's like one of the best successful entrepreneurs in the world. So Elon Musk.
It's an exception.
Also, Abe Lincoln, Walt Disney, Colonel Sanders, Branson, right? The world is full of people who just failed over and over and over again. But I'd like to turn the table around and kind of hear more about.
Let's put it this way. Suppose one of Jack's students has a brilliant idea. How can you help him? His student, not Jack, his student, maybe he still retain his student status in Taipei Medical School and maybe join the nest.
Yeah.
What in any case he failed, then he will come back as a Jack student. And how can you help him in the best resource? Maybe to bring the idea from Taiwan and maybe to use the environment of MIT and to really preach the gap.
Yeah, I think it's a really exciting area, and not many people are willing to work with people from other countries because it's difficult. We have to cross language barriers, cultural barriers, but I think there's a lot of opportunities there. So, introducing people to the ecosystem at MIT or to really advisors or professors or things can be very helpful. I also think there's probably a lot of resources here.
So there's a program of the Chinese government where they're sending postdocs to universities and hospitals in the United States. And these are people who are interested in the biotech field. So our lab is actually hosting 2 Taiwanese right now. So they'll be spending 1 year with us. And the idea of that is to connect them to the rich network of connections among the labs at MIT and to really immerse them in this new environment so that they will come back to Taiwan and try to recreate the same ecosystem here. So that's one program. If the people here are interested in spending time at Harvard, at MIT, as I said, there are two postdocs at Harvard, 2 postdocs at MIT in our lab. And as I said, they're working with us. We actually put them as faculty for the course that we teach. We bring them along with us in all the events. So that's one opportunity for people to
Postgraduate.
this is for a postgraduate. So I mean, maybe the Taiwanese government should also have a program for undergraduates and for graduate students. But they're definitely investing in the youth, in the people who are going to be the future of Taiwan. And I think this is an excellent program to involve in.
So any comments from students from here? I think it's a very unique opportunity. Thank you, James.
I noticed that there are 4 attributes you mentioned about how to fail. It is really about team. I mean, like diversity, or willing to take feedback, or sorry, I forget. But there are 3 things. Other than avoid the death bending, I think that's more about external environment. But I think that most of your points about the quality of the team. And it is very interesting to say that when in Taiwan, the government is trying to do something great, we will emphasize on how much money or how large land we allocate for that specific purpose. So it's really interesting to know that it's different. The emphasis are different. And this is my first observation. It's not really a question, but I'd like to know your feedback also. The second thing is, as far as I'm aware, that there's another model for students to have successful entrepreneurship. Of course, students can get a good opportunity to try if they are still on campus, and so that they can bring their project all the way to the industry. That is one of the models. But the other model will be if some students just go out and get trained in industry, and in the industry they can prepare themselves, and maybe after another 4 or 10 years, they can propose a very specific and feasible idea and to raise the chance of success. So I'd like to know that what's your point about this kind of model compared to the model you are emphasis on? Thank you.
Yeah, no, it's a very good point. So I think you touched on one of the main topics that I wanted to portray. Everybody talks about, when you want to spur innovation, entrepreneurship, everyone talks about we got to buy more computers and we have to have more stuff in the cloud and we need to have, more money available for investment and we need to do all these things. But like you correctly mentioned, everybody talks about it, but no one really talks about the fact that you need to create a culture that is conducive to people taking risks and finding great teams and moving forward. So that was exactly one of the points that I was hoping to portray. It's definitely an acute observation, and I would hope that more people would invest time in creating these communities, because, like you mentioned, startups are run by people, right? And ventures are run by people, and at the end of the day, everything is involved with people. Right. And then in regards to your second question,
Just go out in the industry and try to start after that industry experience. Yes.
yeah. So I think there are models. There's like entrepreneur in residence models, and it's definitely, if you look at biotech, so in healthcare, there's different. There's more tech-focused things. There's like mobile tech, health apps, things like this, which have a fairly low barrier to entry and are pretty accessible to new students. But then there's also things, like new drugs or cell-based therapies or something like this that have very high capital requirements and are typically quite inaccessible to students because you have to raise, millions of dollars to get involved. You need professors involved, and I think especially areas like that benefit enormously from having experienced people. So one of the models that I'm looking at MIT is bringing experienced entrepreneurs to MIT to find technology to start a company based on, and then recruiting students to be not the founders of the company or not the leaders, but kind of supporting roles, which I think is a good balance in that area. Because the people who have worked for a long time get to be CEO or whatever, and then the students get to be one of the first hires. They get to be part of a startup company, but still to learn from people who have a lot of experience. So I think it's a great model and has specific industries could benefit very, very much from that.
How could you keep quality from a company such as Nest Bio that are all working on biotech and also in the same working area that they're all doing on the same thing and gaining capital from the same company? Wouldn't it be fighting and the quality of the products would be similar to what Nest wants?
In the sense that the companies are competing for resources, or that there's just not enough technologies to go around?
How could they keep the quality? How could you manage a company which all does the same biotech, which all does the same category of things, but having lots of groups doing it inside the same space?
Yeah. So I would say that there's more than enough opportunities available for people to work on things that are exciting, that don't conflict with each other. It's definitely something that I have to be cognizant of. We don't, companies that are doing the same thing will be competing for resources. But I think there's so many cool things that you can do that I think there's plenty of opportunities to
it also addressed the difference between biotechnology requirements and the healthcare technologies. Because of the requirements for biotechnology laboratories, they require lots of instruments. And oftentimes they also imply the IP issues. So how did you manage that?
Yeah, I mean, the way you manage it is effectively you need to have people who are experienced and have sufficient resources to invest in these areas. On the private side, you have to raise more money and you have to keep costs very low and get involved with, co-working spaces like the lab space or something like this to kind of expose yourself to other people. But on the academic side, there is opportunities like MIT, for example, is launching sharing equipment for people that are entrepreneurs.
What's your current proportion for the biotechnology part versus the healthcare part?
We're very heavily focused on biotechnology. Yeah. So very little on the other side because there's a lot of people that can provide capital for that. It's very low capital requirements, and often you don't need to have the same level of scientific expertise. So we find that we have more competitive advantage in more highly technical areas.
Since there are a lot of resources in the Boston area, and so there might be a lot of international entrepreneurs from outside of the United States, going to Boston to seek opportunities. And according to your own experience, what are the common problem of those things, and how is it that just entrepreneurs in Taiwan to prepare ourselves against if we want to step forward in into the United States?
Yeah, no, it's a great question. I remember reading an article, I think it's something like, I don't remember the exact statistics, so don't quote me, but I think it's something like 50% or more of highly successful entrepreneurs are actually immigrants to the U.S. So, maybe you have a better chance than people who are there. I'm not sure why that is. It might be like a stronger drive or more appreciation of the resources that are there or something. I'm not sure why. But I think, absolutely there's a lot of reasons, and I think they tend to be very successful and well prepared because they see if you're from there, you may not appreciate the things that are there because you always see. But if you come from somewhere and then you see it's a new environment, I think you're well positioned to take advantage of it. Failure modes would be, for example, the same as it would be for me, for example, going to China or Taiwan, not speaking the language, not being aware of the cultures. All these kind of more social, team-based things, I think are main things to focus on.
So just a quick question, and you had alluded to this earlier. Are there opportunities for students in PMU to do internships with companies around Taipei? Because that's something that is really available to MIT students, and again, you don't have to come to Boston and MIT to gain some experience in the industry or startup companies. Like there are startup companies here and industry here that you could start interning with. So are those opportunities for students?
They usually have quite a few openings during the summer session or internships. But I must say that it's not as often or not as encouraging from the companies because the scale is much smaller in Taiwan. And they do open the internship, of course. But I must say that in the recent years, there's a drawback about developments. So they are more focused in healthcare technologies nowadays. So in terms of the bridging of the IT and healthcare, there are much more opportunities for students for internships. But I think they need to be more encouraging.
There's a major difference when you go to a big company or an established company and you spend 6 months as an intern versus the kind of experience that James was talking about, that you venture into areas of unknown and then you fight with yourself and new ideas every day. So I think those are quite different experiences that we're talking about. For the formal ones, I think that's all established. For medical training, I have to be an intern in the hospital for 1 or 2 years. That's part of the course already. So it's not really triggering me, to do anything new or think of any new idea. All I have to do is just follow everybody and maybe do some very simple stuff at the lowest level of the hospital or the organization. So that type of internship is quite different from what we're trying to talk about here.
So I'm sure there's IBM Type A or Google Type A. Are students going to those organizations?
Those are what we will say that's more like a summer internship. But when you talk about entrepreneurships, you have to think about that the environment here, because the student, as I generally just said, when students take participation in new startups, oftentimes we try to say that they maybe have a new project, or once they accomplish certain things, they may be able to spin off or maybe initiate a whole new project and even a new startup company. But oftentimes students here, they take internship, the psychological, they want to come back to school afterwards. Okay, so they just take it as a training course. They don't take it as a career development. And so oftentimes the psychological part of the students, they are not really that prepared themselves for the entrepreneurship. And we will always say that it's an environment that maybe, as Jeffrey just said, the afraid of failure or the safety net is not strong enough to support the students. So they take that as a part of their career development, but they don't take that as a choice of their career development. Any comments on that? Or we have many young students here. If you want to comment on that, and lack of the internship, we want to complain of the. Yeah.
So I think one brief comment is that I think the internship idea is very valuable, because there's a lot of people who, if you only academically train, you're never exposed to what industry is, it's difficult to understand what even is valuable. So I know for myself, I actually went and worked in finance for 2 years before I came back to go to do my PhD. And that experience there was really two takeaways. One was that, the world outside of academia is very different than the world inside of academia. And I was exposed to it in a sense that made me appreciate what academia offered. So my other takeaway was that I think if I had stayed there a couple more years, I would just never leave. Because it's comfortable. You're making some money, and there's not really much risk, and it really can kill your drive to do something interesting or exciting. And I've seen this. I've worked with some people who are extremely talented, some of the smartest people I've ever worked with, great things, and then they get these jobs, and they just never leave. After a few years, it's like it's like going to jail or something. You're stuck there forever. So.
We must have some feedback from students here. We've got many students here. We have to hear any feedback on them. Any comments from students? Or you all thinking about the match, the contest?
Terry has some experience on
Good.
success and failure.
Yeah, that's good. Yeah. What do you share that?
It's always a problem to communicate with different kinds of people. And for example, this wearable device, in our mind, this is a natural device that can provide useful physiological signal. But in the minds of Xiaomi or in the minds of Foxconn, they regard it as a gold mine. Yeah. So, but the sensitivity and specificity of this device, they don't care. They want to provide resources on that. They want to provide resources on promotion and sales. So this is a big case of the academy and the commercial. So we always spend a lot of time to communicate with these goals. But especially your discussion in the United States?
Well, it's a hard question. I mean, in some areas, for example, if you're creating a drug, the answer is simpler because really you have to be approved by the Food and Drug Administration. So that kind of ensures some level of efficacy and safety. But things like, it's not just wearable devices, but for example, I'm looking at 23andMe, which is a DNA sequencing company that provides insight into health and history. Because they were not certified by the FDA, you're not allowed to use them as doctor's advice. And so now they're like a novelty. And a lot of it is for that reason, because you don't necessarily trust them. So it's a hard, I'm not sure what the right way to deal with like wearable devices. Because people are going to buy whatever they think is cool, whatever is cheap, right? So I don't want to say government regulation or something because it's not usually not the right way to go, but so I don't know.
The regulation will change, and then what I'm saying, the paradigm will be changing. Remember, the FDA only existed for 60 years. So in other words, 60 years ago, there's no FDA. Okay? So the FDA evolves as the industry evolves. Okay, now we have transgenic, now we have genomics. Now we appreciate everybody's gene is different. So no single drug can treat all the people. And that's the whole idea. And that's what the paradigm shift. So of course, when you measure your genomes, when you measure not only your own genome, but probably the microbes in your body, that create a whole new opportunity. So the paradigm change. So of course, we don't know how accurate or how flexible or how useful of those wearable disease yet. But maybe in probably 2 or 3 years, some new technology comes out from James' lab, and the wearable device can tell you, well, you just got a gene turned on, so you don't respond to aspirin today, okay? And that's a whole new idea. I think that's entrepreneurship that we have to address on today, because it's really the new technology and the new opportunity that gave us whole new business areas. And I think that's the whole idea that generally put a lot of effort on today's events. And I myself is very excited because this is a whole new era. This is a whole new opportunity that not many people you can participate in your life. It's probably once in your lifetime. Okay, when you face that, maybe we are in a time to change the government regulatory. Telling FDA, hey, you have to change your regulatory because the drug reviewing system need to be reevaluated. Okay, there need to be new whole system to look at the drugs because probably one drug can treat 10% or 50% of the whole patient populations, and that's the issue we need to address. Okay? Yeah.
James, can you give us some examples of the type of company or what they do that you're trying to foster?
Yeah. So I think first, definitely is the right answer. I think the question is really, it's the same with genomics, right? The genomics side of things raise a bunch of money, everybody who's invested in genomics, but the companies eventually have to do something useful to succeed. So the kind of companies that we talk to, we're looking to, really we're focused on applying technology to biomedicine. So they span, that's the general overarching theme, and they span a lot of different areas. But some of our specific areas of interest include, for example, single cell sequencing. So sequencing of single cells to try and, for example, mine immunosignature mining. So trying to identify individual immunosignatures for targeted immunotherapies or oncology or something. We're interested in microfluidics as it relates to that. We're very interested in microbiome therapeutics. My area of interest is the application of AI to biomedicine, which currently is very much in health apps and genomics, and starting to be involved in transcriptomics and metabolomics, but there's not very much in, so what I'm very interested in now is the application of AI to drug design, because I think that's an area that is ripe for innovation, and it's not really leveraged at the point. And right now, one of the reasons is that the FDA is not super comfortable. So I think the FDA will evolve, and machine learning methods will become more accepted, and drugs designed by machine learning methods will become more accepted. But I think that's an area that we're very actively interested in.
James, I want to go over the Harry Ford's problem, because he said, because we have a lot of problems that some technology is better than others, but their team cannot convince the investor in Taiwan. Oh, did you ever have an experience? How can we convince the investor, especially in Taiwan, go not ahead? Some people, when they judge the technology is good, but however, they deny because I don't know how to say possible. Sometimes, yeah. So there is some device that has superstition. So how can we overcome that? Especially in San Jose, some of the teams, they have a very beautiful CEO, and then they could find a lot of money. So can you give us some suggestions?
Yeah, so I mean, the question is really if you have a working technology that is promising, but there's no money for it to get to actual commercialization and translation, because you need some money to get to the point where you can make money off of the technology, right? So you need to raise money for this area, and that really is the value debt that I was talking about earlier. I think so. There's really two approaches. One hand is the government funding or nonprofit funding that goes towards basic research needs to move more towards the translational side. So in the U.S., for example, there's SBIR grants and other grants that are focused on transferring technology from academia to into industry. And the benefit of that is you take the technology that you currently have, and maybe you can't sell it because you don't have a beautiful CEO, but maybe you just haven't put in enough time to convince people that it works. And often investors don't really know very much about the technology, right? So if you can get it to the point where you can convince people, then it should be easy. And on the other hand, there's a lot of venture out there, kind of dumb money, right? So money that's available, but doesn't know, but is not capable of really deeply diving into the science, or just doesn't have the time to do so, right? Because if you were managing a $10 billion fund, it doesn't make sense for you to spend a lot of your time investing like $100,000 or $200,000 or something. It just won't give you the returns that your investors into the funds need. So the other side is trying to get investors to go earlier and earlier and be more and more scientifically trained, I guess, too. So kind of try and close the gap on both sides. I think that's the way to do it. Or just go get a very attractive CEO.
Coming back to your previous question, AI in drug discovery become very hot lately. So, and I think the SoftBank just made a heavy investment in one of the small companies. What do you think about that? How do you view, will there be one dominant player or few dominant players in this category?
Yeah, so I think in any industry the trend is for consolidation, right? So, but at the same time, in new industries, there's always consolidation and then disruption, right? So you can look at the computer industry, for example, right? Apple didn't really exist for a while, or if you remember Nokia phones, they owned the whole market, right? And then they were disrupted by new technology. So I think as long as new technologies come out, we'll be able to get rid of these agents, right? And your first question was regarding application of AI into drug discovery.
Yeah, so it's very interesting in that area.
Yeah. So what specifically, what area?
In general discoveries, how did you apply AI for drug discovery?
Yeah. So I think the AI in drug discovery area, no one's really figured out how to do it, right? So it's like right on the forefront of technology. People use, so one of common methods is virtual screening. So people will do, they'll screen 50,000 drugs and then try and use AI to find the ones that could be useful in the future. But it's kind of for me, that's not a very interesting application. It's kind of standard. I think there's really interesting applications in generating new molecular entities. So there's very little work being done on application of AI in structural biology, for example, or biochemistry. There's a lot of, for example, Schrodinger, there's a lot of molecular dynamic simulations that focus solely on quantum mechanical, molecular mechanical simulations of proteins or other compounds. But there's not much AI being applied to those structures and trying to learn from those. And I would like to get to the point, the long-term vision is you get to a point where you say, I need a new antibiotic, like generate 10 examples and try them all out. And I think maybe it's impossible, but I feel like that's the kind of area that's looking towards.
Well, I think that's a great idea. Except that in biomedicine or eventually in healthcare, you need validation. And validation is very costly. Virtual screening and prediction for new molecules, these are in silicon, so it's not really that expensive. Once you go to in vivo and the clinical trial, how do you justify the risk and the cost that's involved in these type of ventures?
Yeah, no, that's a great example. So another potential application of AI is to, identify molecular compounds that are most likely to succeed, for example. I mean, I know of a couple companies that's what their main focus is. So they'll look at the portfolio of drugs that you're interested in using to get the therapy.
So, right, but before you know that your model actually predicts the possible molecule that's most likely to succeed, you have to know those other models that they're not likely to succeed by doing the validation, and which is quite expensive again. Yeah, in order to do the negatives, which you probably have to do a lot, right? In order, then you rank them and you get the positives. Right? But you spend as much money on the negatives as much as the positive, except that it's hundreds of, in terms of scale. The kind of money that you will be spending on the negatives is like several magnitudes.
No, it's a deep insight, and many people forget about that. If you want to build a successful prediction model, you need a bunch of data to train it on. And I think so what's interesting is in the AI space, the actual algorithms are becoming commoditized, right? So you have like TensorFlow, you have all these deep learning frameworks, Cafe, that are free. So, yeah, exactly. So the thing that's becoming valuable is actually the data, right? The data sets and these exact things. So I think, it's kind of a chicken or the egg problem. How do you generate the things? If you don't have money, well, how do you get money to generate the things? But I think the first person who can kind of bootstrap that and get to the point where they have that data set, then you have something very valuable. I think it's great.
Any more comments or questions? We still have a little bit of time before lunch. So you have to ask questions before you can get lunch.
Hi, recently I just saw an article about the 6 type of people that you must have in a startup group, and the 2 type of people is, I believe one is expert who has the technology and information creativity, so the technology. And the second type of people is the guy who is familiar with industry ecosystem, knows how it works in the industry. So is there any type of experience that you have handled before that the 2 type of people are maybe fighting or have a not matching a positive issue?
Yeah, no, absolutely. Happens all the time. I think one of the biggest conflicts are people coming from the business side and people coming from the science side. So people on the business side have spent 10 years learning about business, and they think that's the most valuable thing. And people from the science side spend 10 years studying science, and they think that's the most valuable thing. And both of them don't believe that the other person actually brings anything of value, right? So actually caused a lot of problems. And I know of companies in which that has led to the either firing of one people or the dissolution of the company entirely. And it's kind of sad because if you think about all the promising technologies that were not brought to market just because of team problems like that. And I think the solution is, one, interdisciplinary training, right? So taking scientists and having them at least be exposed to the business side of things so that they appreciate that there's a lot that they don't know, and vice versa. So taking business side people and having them exposed to how difficult science is so they understand that the other person's actually bringing a lot of value. I think that's one of the things.
Great. Any more comments? Two more questions, then you can get done. Or I should turn off. Okay. Good.
Hi James, I'm Jean. I have confessed, I'm actually walking, so I probably won't get lunch, but it's okay. It's really a great opportunity to hear from your talk. And you got me at first when you mentioned how Hangzhou felt, because I know people in Hangzhou, and I'm really curious about your perception. How do you see people in China and the people in Taiwan are embracing new technology, and how are they trying to stop? Because I'm working people with those in Taiwan, and I really want to hear about your perception. How do you see it? Thanks.
In what sense? In which
About the paradigm shift. Because I've been working with people working in biotech and in scientific research, and I know that friends of mine, they're going to China, a lot of them, and because of the government policy, there are a lot of funding throwing onto people in China, but probably not as much here. So as the professor mentioned earlier, there are people are taking risks or not is something probably a lot, especially those young students, young generation. They are probably debating with themselves once they get graduated. So I wouldn't point a finger on any single company, but let's say there's a huge giant business already there, and there is a startup that is trying to do something really brilliant, something new, and they have to decide whether they are going to take risks. So what would be your suggestions to those young generations, and how they choose?
You guys ask tough questions.
Thank you. I really appreciate it.
So I think the first thing I would say is that, from my, and this is my first time in Taiwan, but it appears to me that people here are extremely technology friendly. Everything that I've seen is actually very technology focused. Even the buses are way, more advanced than they are in Boston, for example. So I think this is a great spot to be if you want to focus on the application of technology to health. And I agree with you that I think biotechnology is at the point now where computer science and computer engineering was like 50 years ago. So there's real opportunity to kind of take those skills, which are, Taiwan is very strong in these areas, and in biotech areas. I think that's a natural progression. And then your second question was about students trying to decide between going to take a job or starting a company. It's hard. So I think there's two kinds of risk, right? There's risk of, it depends on how you want to allocate, what your goals are, and how you want to allocate your energies, right? So I don't know if you know, for example, Warren Buffett. Have you heard of Warren Buffett? So he's one of the most famous investors of all time. I think he's like the second richest guy in the world or something. So we'll take an analogy in portfolio theory. So in finance and portfolio theory, the standard approach is you have to reduce your risk by diversifying your projects, right? So the more projects, you have to reduce your risk by investing in many different assets. And the more assets you're investing in, you can reach this kind of like Pareto optimal curve. So you can think of the allocation of your time in the same way, right? So if you focus all of your energies on one project, you're never going to get to that Pareto optimal curve. Whereas if you distribute your energies between different projects, you can actually end up getting closer to the Pareto optimal curve. So that's the first thing I would say. And the second thing is, if you talk to Warren Buffett, for example, he doesn't really diversify his work. He invests very heavily in very specific companies. And if you would ask him, he'd say, Warren, like, why do you, invest in one company when all portfolio theory says that you reduce your risk by investing in many different assets? His answer would be, yeah, you reduce your risk of underperforming the market, but if your goal is to outperform the market by investing in a bunch of different things, you actually are less likely to do that. So it depends on what your goal is, how risky something is. I guess would be my answer. Yeah.
Great. Still, I think one of the major takeaway message is that if you want to take the risk, it's easier to take the risk when you're younger, right? Because there's always a fallback. When you're 50 or 60, and you want to take a risk, there's not much, thing that you can fall back upon. And when you have family, you have children, very tough. So, and actually, as we talked about, most people will fail anyway. But the value will become one of your medal of honor, right? Like the Purple Hearts. You did not win the war, and you got injured in the war, but it's actually a good thing. It's an honor, and it's a very precious experience compared to those who never risk and fail, right? Even if you set out eventually in a big company or in a bigger organization, but you still bear the experience and the spirit of risking it all and try and fail, right? And of course, it'll be even better if you succeed. And there's always a chance. So I think that's, for me, that's a very important take-home message.
Yeah, no, I agree. I mean, I remember when I quit my job to go back to school, and everybody told me that it was a bad decision. Everybody I was working with was like, why would you do this? But I knew that was something that I wanted to do, and if I never did it, then I would fail by default, right? So I guess you have to define failure for yourself.
Great. Okay. One last question, because I thought we just wrapped up this session already with Dr. Lee's context.
They're not afraid to fail.
If a new company and went through the four problems and to become to be stable, what the first problem they will probably encounter because they have no experience? And do you have any instruction to this situation?
The first problem after the things that I talked about?
After the started company, the four problems. Yes.
What would be the first problem after creating it?
Yes. Because they went through the four problems, there will be a stable company. And what problem they happen when they are a stable company?
Yeah. I mean, there's so many problems that it's easier to say how to avoid, what would they not do? But there's so many failure modes for early stage companies. I think they span everything from, not having money to team breakups to the technology not failing to there's a huge amount of uncertainty there. So I think it's hard to pick a certain specific order.
The most important take-home message today is if you want to try, you try earlier. Try when you are young. Okay? And I think our physiology clock tells us it's time to eat. So let's give Dr. James Weis So we wrap up the session. Okay, thank you all.